My name is Gwilliam. I'm going to give you a quick run through on collisions of mechanical objects as required by what's usually called the M1 syllabus. In this we assume that we're dealing with two identical balls which differ only in their mass. I'm going to use the principle of the conservation of momentum in a collision. This means that the momentum beforehand is the same as the momentum afterwards. I'm going to do it with a numerical example first of all. So the laying out of this is pretty important. So we will have a mass of, let's say, 2 kilograms colliding with a mass of, let's say, 4 kilograms. Probably going to be something like bowling balls. And we know the condition before, we know the state before. So we'll assume that this is moving this way with a speed of, let's say, 5 meters per second. And this one here is moving this way with a speed of 2 meters per second. You might like to think why that couldn't be 7. I'm not going to explain why, but you might like to think why that couldn't be 7. And then we're going to have its afterwards. And what we have in these questions is that we have, and we'll see now, 6 possible numerical values. We have the mass of the balls, that's 2 values. We have the speeds before, that's another 2, and we have the speeds afterwards, that's another 2. Typically in these questions you'll be given 5 of those values and asked to find the 6th. So just to illustrate the principle here, I'm going to say I don't know what's happening to this one afterwards. So I'm going to call this V. And I'm going to label them. It's a good idea to label them. So I'm going to call that the velocity of A. And let's assume that this heads off afterwards with a velocity of, let's say, 3 meters per second. There's another factor which comes in here, which is bounciness, elasticity, but we're not going to deal with that because this is only M1. So what we have then is we do by the conservation of momentum, which is something that Isaac Newton first worked on back in the 1600s. We have that the momentum before is equal to the momentum after the collision. And the momentum is the mass times the speed. Well, technically mass times velocity, but here we're dealing with speed. So it's 2 times 5 plus 4 times 2 is equal to 2 times VA plus 4 times 3. And this is very characteristic. We get this equation, and if you see we've got our 6 things, what will happen in the exam will be that you'll get one of these will be an unknown, and you just have to solve the equation. So here we get 10 plus 8 is 18 is equal to 2 VA plus 12. So 2 VA is 6, so VA is 3. So I just made this question up, but as you can see, the implication here is that while that one moves away at 3, this one's also going to move away at 3. They're actually going to stay together as they move away. And we ought really put units in as well. And that's it.